Over the last 3 months, I recorded every token my AI tool consumed. The benchmark was clear: 208 million tokens in a single week. 100-to-1 ratio of input to output. The usage profile has shifted. Reasoning model and tool calling make agent more capable, but that capability comes at the cost. Most of them, that volume, is comprised of the tool reading the code, understanding context, exploring, completing the feedback loop, not actually writing it. 2 years ago, the math was pretty simple. You send 2000 token and you get 2000 back. One request, one response. The cost was predictable. It was pretty much a deterministic path. Today, to get those same 2000 token back, agents send roughly 200,000 token in, 100-fold increase. But it is not the waste. It is now the agentic system. And how it works: the model reads, plan, act, checks, loops. Every cycle adds some intelligence and maturity, but it also adds token, so to the cost. We will walk through each and every claim with detailed evidence, experiment, real dashboard, real session, and real numbers. First, we'll cover here the key topics and highlight the data, the patterns, the market signals, and then we'll move straight into the hands-on session where we'll reproduce every result you will see here. Stay with me. I'll show you every number with the proof, and then I'll show you the system that actually cut my cost 5 to 10 times. Here I am with my Visual Studio Code. I'm going to demonstrate a very simple example. I attach a markdown.py file and ask an BS Code agentic with my local Quen 3.6 DGX 27B that can you fix this. Now in agentic workflow, it is actually handling things with the different steps over validation and other stuff. And finally, it fixed the bug. There was some bug I left in the script. It fixed it properly and worked fine. Now, let's understand how much token it consumed. So if we see here, from 6:39, the session actually began markdown.py, and then the session took up to 6:46. No, I think 6:42, if I'm not wrong. Yes, the 6:42, the session kept, and there was around 15 step over. The markdown script was validated, and the final outcome was printed on assistant. And if we see here, we exactly see this outcome here printed. But let's change the script and let me see what 2 years ago, how it could have been handled. So here, I took a simple non-agentic chat prompt. I passed the same file and I passed the same component as a prompt. Now, if we see here, it is also the same thinking model. I'm not using anything otherwise. It's a thinking model and it did the process. But here by the way, it is not an agentic process. It doesn't have access tool. It is just a one request. And then it returned the improved script. Mostly work, but that's not our plan. When the complexity will rise, this will become very complicated for a chat agent to complete it. But it did all it's supposed to do. Returned everything. But what I want to show you is this parameters. So if we go towards the end, what did happen? 1441 to 2650. We send less and we got more. That's fine. There was 501 agentic reasoning. Total, we spent 4000. But if we go back on this particular one, across this many requests, if we see from 649 where we actually finish up process, we were around 23,000, if I'm not wrong, from this particular process. Yes, we were around 23,000, and we can see here how many requests we have sent, around 20,000. So roughly, to complete this request, we have spent more than 140,000 tokens. The same outcome we achieved here with 491. Now, it is not about one is right and one is wrong. It is about telling the different settings and how they improve, how they actually impact on consumption of different tokens and your cost markings. This is exactly what is happening. A company can offer you 10,000 chat requests in a $10 subscription because it's a deterministic, and this is exactly how it can cost. But a company cannot offer you the agentic solution by counting an agent completion as a request because it's a non-deterministic part. We really don't know. In this case, it finished at the 8 or 9 turn. In other days, it might finish on the 10th turn. In some case, it might finish on the 3rd turn. There is no way to identify how much overall cost is gonna incur. So therefore, it's a very common and understandable practice that industry want to move on. Now, coming back to our understanding, does that mean we should stop using AI because agenting is too complicated and costly? No, I think that it would be very counterproductive. Let's see what industry see. Now, this is an interesting interview given by the Uber CTO to AI Magazine. And they have done a very good story. Here see Uber's research and development expenses went up by 9% year on year in 2025, hitting 3.4 billion with the AI cost. Now, I don't believe that is over-exaggerated number. It can definitely happen. But more importantly, the concept that industry is practicing token maxing, it is completely boomeranging right now. And this is not something I would say speculated number, because I have seen and validated this number myself personally and with the clients as well. 500 to 2000 is a moderate use. Person like me who has extreme use, around 2 billion tokens a month, wow, that number can really go very high. But it is not something a made up story. That he can definitely confirm. Recent validation by even Microsoft, the Finance Yahoo published this nice article and a news story where they butt backed on cloud code and how we're gonna use it, but they want to switch back to the GitHub Copilot. This is perfectly good mode. On an average, I'm growing my token usage at 10 to 12% a month on month. Right now, I'm not at 2 billion, but I can easily see myself in 2 years, or at least 1 year, I would be at a 2 billion per month. So this all matters. Industry recognize this. This is a wonderful article by Hedging on an X platform, and this is what exactly we see. The agentic use has actually crossed the unicorn mark, and this is where this per token AI compute cost has to come in picture to sustain. There is no other way we can do. There is also the hypes, good estimated numbers, and I also agree with that. No matter what we do, but if we allow user to actually access the frontier model for all the world, we are talking about in range of 2,500 to 5,000 US dollar per month of a person. Now the question goes to how much multiplier a person can generate on top of it. And that's a real question, but this is a staggering number. So we definitely need to find how we can reduce this number by improving and bettering at our own economics. I have published this article and I'll leave this link in the description below as well. GitHub Copilot's new AI credit and how to survive meter software shift. My point is not targeting the Copilot. It's just that happening right now. It's actually applied on every other platform. However, in this, I have described in 4 different pillars how to achieve that 5 to 10 times saving within local and flagship models, and implementing similar tier-based routing capabilities. And I'm not saying a routing capabilities means going to the third-party routers like Open Routers and other. They can route on a pricing basis. But you must need, or every enterprise must need, an intelligence router that based on a complexity problem, either by deterministic or non-deterministic part, it can handle this smart routing based on either a problem domain, the complexity of the problem, or the team and structure where it is coming from. And that can certainly help as of today. These are the 2 sessions I'm talking about. Let's see how this session actually look like. This particular session, I spent £8 on a input tokens and around 0.21 pound on an output token. But if we see this particular example in end-to-end, this is what I sent using K2 on Azure. It was an orchestrative solution where the frontier was controlling the orchestration, but all the hard work and all the work was actually picked up by sub-agent. For example, this sub-agent was Raptor Mini. Raptor Mini was exploring everything. If we go on under the sub-agents, they were local agent. They were running on my Spark DGX Quen 3.6. You can see here, this agent has done most of the work, picking up, creating the logic, then continually run the test to fix it until they manage to fix everything. They keep going, and we can see here towards the end, they managed to fix all the tests that we were anticipating. All the 10 tests pass, and then keep going and finally closing the loop with the feedback. It was a very complex architecture design that I was trying to publish. And why I would say that it was complex, it was not an average solution I was after. I was after one of the semantic node where I was building a test application to see whether I can use the web GPU and WASM capabilities to build a whole micro RAG into the user browser session. This is a RAG which generally stays within the browser. It doesn't need any external endpoints or a model. It used the transformer.js to download the correct embedding models, does the embedding on locally. It uses the SQLite as a WASM component that can be downloaded and work like a vector database. It does not leave the browser. It is completely offline. And here you can see that it works perfectly fine, that when I select a particular node, it actually tells that how many semantical nodes been related to. The next phase, I'm going to implement a local chat as well, so someone can chat with their nodes too. This is something I'm intend to release as a sort of a fun test example project for everyone to look into it. But it's a complex project. That's the whole idea I want to show. Like if I'm searching here, weekend, then it actually gives me a perfect weekend. We can find everything that included by weekend, whether that means a weekend, semantically meaning weekend, or actually a keyword-based BM25 search. It does the hybrid search behind the scene. So to achieve that particular example, this was roughly around 1.5 hours of agentic solution where the orchestrator run for 1.5 hours, and it invoked more than 30 plus sub-agents to do some individual lifting tasks. But even with that, I offsetted more than 30 million plus tokens or 40 million plus tokens with the sub-agents. And I only managed to spend around 8 million tokens on K2 6. And that's on Azure, and that was my cost. If I compare this roughly cost, if I spend the same on GitHub on a GPT-5 or Anthropic, I would be somewhere around $400 to $500 a session if I'm paying with the API cost. But with just a mid-tier Kimi K2.6 and also my local models and using some models like Raptor Mini and others, which are generally designed for context explorations, by doing that pattern in the right way, I have not just squeezed, or I have not just reduced my cost of achieving the meaningful outcome in very affordable way. Not just that, but I also increase my agentic capabilities to handle all sort of such promotable work in future. That's where we need to think about. It's not about using AI or not using AI. I think if the argument is the humans now are cheaper, these arguments are ridiculous. It's not a technical argument. They're not engineering argument. If you are accepting a problem with no solution, then person is not an engineer. The engineering solution means we need to go and find and dig a solution to fix this problem. And to fix this problem, the solution with the agentic is to combine 3-tier architecture where we can route basis on the requirement, the complexity, and the source where it is coming from. Every claim in this session was backed by data. The usage profiling is clear. Reading and understanding code consume bulk of tokens. Feedback loop and critique loop also have their fair share. Writing code is a smaller share here. This is not a problem to fix, it's the reality to design around. A 3-tier system with a smart routing cuts the cost 5 to 10 times. Send easy work to local models, reserve the frontier models for tasks that you actually need them. Do these 5 things now. Stop testing models on just benchmark. The oblique benchmarks are not the best way to understand how models are gonna fit into your own problems. Track the cost per record. Split the hard work and the lighter work that can be easily routed. Add the data dashboard. Fix how you can send the context to correct models. If you want to go deeper on context engineering for coding agents, I have a free course pinned in my YouTube channel homepage. It shows you how to control what context the model get and why the control cuts the cost even more. If this helped, watch the rest of the AI Dev Economics series, which is about to release in 2 weeks. Subscribe and press the notification bell. We are going to launch this 6 series in coming days, and we will be working on that semantic nodes which I have shown, and a multi-agent workflow, the cost effectiveness, exactly how the behind the scene we managed to build that whole paradigm. You will not miss an episode. Follow me on X at the localm_tubes. I run a live session there for most weeks. Bring your questions, bring your dashboards, and bring the best conversation happen. We can build together there. See you next time when I see you.